to everybody, wherever you may be tuning in from across Melbourne, Victoria, Australia, and across the world. It is wonderful to have you here. My name is Shelley Dolan, and I am the Chief Executive of the Peter MacCallum Cancer Centre. And I'm really delighted that we are here today to celebrate and mark 25 years of the Peptide Receptor Radionuclide Therapy. I'm going to say PRRT from now on. So this is a very special event, and I'm really excited to be tuning in myself and listening and learning today. This program at Peter Mac has pioneered and is part of a fundamental shift in how we treat neuroendocrine tumors. The advances we have seen are outstanding, and as you will hear, this program has been life-changing and life-saving for the many people, patients that have been touched by it. These credits are the result of many dedicated people in a large team. And that team has been led by Professor Rod Hicks, who is, of course, here with us today. And I think it is a really important opportunity to celebrate his life's work and for us all to gather together to hear about that and also to hear Rod himself speak. I am really pleased that we could bring everyone together in a time when it is so difficult to come together physically and at a time when there is so much challenge across the world. Isn't it wonderful to celebrate something positive together and to bring Peter Mac and the Neuroendocrine Cancer Australia communities together with patients, families and friends. So we're very lucky to be here today. I'm going to run through the order of proceedings, but before I do that, I would like to do the Acknowledgement of Country. I would like to start by acknowledging the traditional owners of the land on which I am presenting from today and from which many of us across Australia are from. So I'm presenting from the Wurundjeri people of the Kulin Nation, and I pay my respects to their elders, past, present and emerging, and anyone that joins us today. During today's event, we will hear from a range of speakers across 2 different sessions. In just a moment, you will hear a message from Her Excellency, the Honourable Linda Dessau, the Governor of Victoria. Then we will hear from Simone Leyden, who we're very, very lucky to have with us. And I met Simone for the first time last week and was delighted to hear about her journey and her important role. So Simone is the Chief Executive of Neuroendocrine Cancer Australia, and she will be giving us a short presentation. Then we will go to Professor Rod Hicks, as I said, who will tell us a lot more about this program. And then we will hear from Mr. Ross Flanigan, who is a patient with neuroendocrine tumour, and we will hear his story. After the break, Associate Professor Grace Kong, who's here as well, will lead a mock multidisciplinary meeting, walking us through the typical process where the whole of a multidisciplinary team gather to look at a patient's findings, their pathology, their scans, and decide upon the treatment plan that they will go through. This is a wonderful way of making sure that people with cancer get a whole multidisciplinary plan. One of the things I said to Simone when we met is, I'm old enough to remember when I was a cancer nurse in the UK at the Royal Marsden, that there was a time when such programs were not available to people with rarer cancers, and particularly people with neuroendocrine tumors. And I remember stories of patients going from this clinic to that hospital for years trying to get a diagnosis. And sometimes presenting to us at the very end of their life when little more could be done. So it is a wonderful opportunity today to celebrate the progress that has been made. And it is wonderful to see such progress in my lifetime due to the wonderful people on this call today. So I feel really privileged and honored to be here today to join everyone and to listen and learn. Finally, part of learning is often to ask questions, isn't it? And so, as ever, we've all learned how to do this, haven't we, over the last year and a half? And so there is a Mentimeter program here, and you can ask a question by going on to, as you can see on the slide, www.menti.com and enter the code for this program, which is 79280034. Now, without any further delay, I am delighted to introduce Her Excellency, the Honourable Linda Dessau, Governor of Victoria, who has provided us with a short pre-recorded speech. Thank you, Jai.
Hello to everyone, wherever you are. I'm really pleased to be joining you all to celebrate the work that's being undertaken at Peter Mac in relation to neuroendocrine tumours. A key part of that is the Peptide Receptor Radionuclide Therapy, now conducted there for a quarter of a century. I like expressing it as a quarter of a century. Somehow it always sounds like longer than 25 years. I don't know why, but either way, it's extremely impressive. Now, I was tempted to launch into a description of PRRT, but I'm conscious to resist the tendency to describe something to a group of people who are already right across it. And the more so in this instance, when many of you watching this are either clinicians or technicians in the field, or the direct beneficiaries of their expertise. I certainly don't know all the ins and outs of the treatment, but I do know how much it matters. I know how fortunate we are to have it, and how fortunate we are to be served here in Victoria by the world-renowned Cancer Centre. In fact, in the context of this event, a special congratulations is due to Peter Mac as the first centre outside the European Union to have received accreditation as a neuroendocrine centre of excellence. Terrific technology is, of course, just one part of that excellence. We are absolutely blessed by the expert practitioners and researchers in our midst for their skills, but also for the care that they show. I've seen it close up as a board member of the Unicorn Foundation before I commenced in this role. I was privy to Professor Rod Hicks's commitment to patient care. He was passionate about the science, but the patient, the person, was always at the heart of his work and his advocacy. I understand that Rod's stepping back, and I'm very pleased for this opportunity to celebrate his contribution and his great legacy through the team, the knowledge and the culture that he's helped to build. It's also been my great good fortune to experience the work of another contributor in this field. The CEO and co-founder of NeuroEndocrine Cancer Australia, Simone Leyden, is an absolute star. I can't imagine that anyone present today doesn't know that. She's as charming as she is tenacious in chasing every aspect of the best care and support for NET patients. So, I'm not really sure if I can actually wish a happy 25th birthday as such to PRRT, but I can certainly say this. Thank you to CEO Professor Shelley Dolan and everyone at Peter MacCallum Cancer Centre and at NeuroEndocrine Cancer Australia. Thank you for what you do at all times, but particularly for what you've been achieving for patients across what have been challenging times of this pandemic, for you as well as for them. I wish you and all of those at this virtual event the very, very best.
Fantastic. It's so nice to actually hear from one of our first board members, the Honorary Linda Dessau. And unfortunately, she did have to leave us to take on that role. I don't know how she made that choice, but obviously, you know, it was a hard choice. But she's a wonderful advocate for us and has been an incredible mentor. So, hi everybody, and thank you so much for being part of this really important event. As mentioned, my name is Simone Leyden. I'm the CEO and co-founder of what was the Unicorn Foundation, now NeuroEndocrine Cancer Australia. So I just wanted to talk very briefly about some of the things, or for those who are not aware of who we are or what we do, some of the things that really drive our organisation, but also some of the really exciting things that we're working on this year, and something that we'll be really calling on our dedicated community to support us in. So for those of you who don't know who we are, we formed around 11 years ago due to the experience we had with a family member, and also obviously the strong connection we actually have with this wonderful institution of Peter MacCallum, with many of our key champions of care that we had with us today. So our vision is to be the champions of early diagnosis and a cure. And as Shelley mentioned, you know, our patients do still unfortunately go for very many years with misdiagnosis, and currently it still sits at around 5 years. So we really, really want to work exceptionally hard to try and get that time down, and we're driven by doing that through our key mission. And we really these sort of come under the 5 pillars of what we do, and that is to support. As you can see, we support patients and their carers through groups, support groups, through telehealth, through our support services. We lobby and advocate for new access, so access to new and appropriate diagnostics and treatments. We raise awareness and knowledge of neuroendocrine cancers within the medical community and general public, and we really try and strive and encourage research. So some of those, whilst that sounds like a great mission, what are we actually doing in practice? And you can see some of the things we've highlighted from last year, and some of the key sort of numbers around that. And I won't go through too much of that, except to do a bit of a shout out to the incredible advocacy work that our WA community did, led by our consumer advisory group member, Michael Doyle over in WA, who petitioned and got handwritten petitions of signatures to really drive forward a real referral, a better referral outlet and then trying to drive this centre of excellence sort of idea that we are so lucky to have on the Eastern Seaboard board with Peter Mac and with Royal North Shore in New South Wales, and trying to drive that in WA. And the other thing to highlight, one of our key things that we did last year was developing the first Royal Australian College of General Practitioners online modules. So that's a Category 1 course, and that was due to the tireless efforts of the steering committee who put that together. I think it was a 3 or 4 month process of an incredible amount of work, and that was led by our wonderful project officer, Meredith Cummins, who I think would be on the call. So shout out to her, who's worked so hard for that. So you can see the other things, obviously, as Shelley mentioned, you know, and I don't like to use the word pivot, but we had to pivot and we moved everything online, and we hope that we were able to deliver some really important resources there for our patients. So what are we doing this year, and how can we, you know, drive this even further? We were really fortunate and excited to, after years of advocating for the announcement of an optimal care pathway for neuroendocrine tumours, was announced earlier this year through the tireless work also, and the support of Cancer Australia and the Federal Health Department, and the Minister Greg Hunt made that announcement. So what does that mean? It means that neuroendocrine tumours are finally recognised as an important disease, but also it joins the other 15 optimal care pathways that of other different cancer streams as well. And with the latest Australian Institute of Health and Welfare data showing, you know, it's predicted or estimated that over 5,000 Australians will be diagnosed with neuroendocrine tumours this year. That makes, as a collective group, neuroendocrine tumours the 7th most diagnosed cancer, behind breast, prostate, non-Hodgkin lymphoma, lung, and some others as well. But seventh most is quite the statistic for a cancer that a lot of people potentially haven't heard of. So we really will be driving a lot of awareness around that, and through that we will be developing our first ever national action plan, which we hope to launch at least by the end of this year. Because there's no point having an optimal care pathway if we don't have some key actions in place to support that optimal care pathway. So what we'll be asking for is, of course, support. We fundraise for our telehealth nurse service, and we would really like government funding and support for that to ensure that we can sustain that, but also grow that. We're also looking for funding for development of more information and resources. We know that 70 to 80% of patients seek out their information from our website and from our information that we send to hospitals, etc. So we really do need some support to ensure that they're up to date and accessible to all. We really need to do more to educate healthcare professionals to drive this earlier diagnosis, and to get more and more GPs signed up to that important course, of which we've had nearly 400 or over 450 signed up since and educated since November, which is no mean feat over this really busy time of COVID. And it is now also accredited for nurses, which is wonderful. We would love a national public awareness campaign about what symptoms to look for, what is neuroendocrine cancer, and what are the effects of it on not only the person, but also on the community as well. Obviously, the optimal care pathway will pull all of that together, but we'd also like support for the National Tumour Registry, Planet, which we are so excited that is now rolled out at 5 key cancer institutions across the country, and the associated patient reported outcome app, which is one of a kind, and will really drive important research and information around treatments in the future. So we would love government support for that to sustain and grow. And we would also love support for what is this excellent model of a centre of excellence, and have that around the country. So learn from what we've got here in the incredible work of what we've got here in Victoria and in New South Wales. We've also got in Queensland, South Australia, WA, and shared care models with our friends in Tasmania and other, not that I'm saying Tasmania is regional or remote, but in shared care models with other regional and remote areas, to ensure that every Australian has access to the amazing work that we have at these centres of excellence. And obviously, lastly, what we would really ideally love and is more targeted research into the key areas around what we see are the unmet needs around early diagnosis and outcomes with the vision for a cure. So we were looking to advocate for more support through the Medical Research Future Fund for targeted research in neuroendocrine tumours. So that's a quick snapshot. I hope I haven't talked too fast, but it is an honour to be here today, and I really appreciate the partnership and the incredible work that we are able to do with an incredible institution that is Peter Mac, and it drives what we do to support our patients. So thank you for that. It is my honour that I believe I will be now introducing the wonderful and the pioneering, and not only also all of those things, but also a dear friend and board member of Neuroendocrine Cancer Australia, Professor Rod Hicks. So Professor Rod Hicks is a professional, oh, see, look at this, I'm not very good at the professorial fellow of University of Melbourne, and until recently was the director of the Centre for Molecular Imaging and Therapeutic Nuclear Medicine at Peter MacCallum. Rod has been a pioneer in this space here in Australia, and his work has had enormous influence across the world. So without further ado, I welcome Professor Rod Hicks. Rod, you're just on mute.
You would think after 18 months of virtual meetings, I would have worked out how to unmute myself so I could talk. So thank you, Simone. It really is one of my great pleasures and honours in life to be associated with you and the Neuroendocrine Cancer Australia. And so what I thought I'd like to do over the next 15, 20 minutes or so is to look back on 25 years of PRRT at Peter Mac, our move from East Melbourne in 1996 to Parkville in 2016, and the renewal of our ENET Centre of Excellence just this year. It's interesting to consider that 25 years is in fact half of what was considered the war on cancer that was established by Richard Nixon with the National Cancer Act back in 1971. Cancer is, of course, the emperor of all maladies, and now one of the major causes of death throughout the world. And how far the medical profession has come in that last 50 years. We've gone from being respected for our opinions, even when they were wrong, to perhaps being respected for our deep knowledge of science and cancer. And that's been a major advantage of the last 25 years, how far we've come in understanding cancer. When I began my work and interest in neuroendocrine tumours, it was really a largely unknown tumour. It had no profile at all. In recent years, it's got a little bit more profile by high-profile people like Steve Jobs and Aretha Franklin developing and then dying of this particular form of malignancy. In fact, a number of years ago, the medical team of Steve Jobs came out to Peter Mac to interview me to see whether perhaps we could offer him treatment at that time. And he elected not to come to Peter Mac to be treated in the United States, and in fact had a liver transplant. But I might have become even more famous if perhaps Steve Jobs had died under my care. As George Bernard said, a doctor's reputation is made by the number of eminent men who die under his care. But in fact, we've had many important patients, and none, I don't think, any more important than the owner of this scan, who was a very dear patient of mine. And unfortunately, this was the last scan we did of her when I met her new husband at that time, and unfortunately had to tell her that we had nothing more to offer her. Her name was Kate, and she was a beautiful soul whose death led her brother John and her sister Simone, who just met, to establish what was then called the Unicorn Foundation. The Unicorn Foundation has obviously morphed not into a rhino, as you see here, but rather into Neuroendocrine Cancer Australia. And I thought this quote is particularly apt for Kate. There are stars whose radiance is visible on Earth, though they have long been extinct. There are people whose brilliance continues to light the world, even though they are no longer among the living. These lights are particularly bright when the night is dark. They light the way for humankind, and certainly Kate has continued to light our worlds. If I've learned anything over the last 25 years, it's the lives that live outside our walls that really matter. And although we look at these scans and are really chuffed to see the improvement in the scan, what really has brought me much joy over the years is getting Christmas cards like this that came from a patient called Jan, who we treated for over 10 years in his battle with neuroendocrine tumour. Those children were born after his diagnosis and after he started treatment with him. And he went on to live, unfortunately, longer than his wife, who died of malignant melanoma, but lived long enough to have his children adopted by his sister-in-law and brother-in-law. And they have a very happy family now, and very much.
Sorry there, Rod. I think someone might have taken control of the PowerPoint. We might go back to where we were.
do I have to are you going to be able to advance it for me, Joe?
Yep. Just we're up to. Have you got control now?
I hope so. No, it's giving me a clicking noise.
Mm.
Perhaps you can advance it for me, Joe.
Yep. No worries. Just say next slide.
Next slide, thanks. In another case, this is a series of scans that I often show at meetings to my colleagues, emphasising the depth and durability of the response that we sometimes see to PRRT. But the more important image for me is the one on the right, which is of this dear patient of ours, Daryl, who's a passionate Essendon supporter, and at the height of the peptide saga that anyone in Victoria knows about with the Essendon Football Club, I was able to arrange for Daryl to meet his hero, Paddy Ryder, and Daryl was able to explain to Paddy that there were actually very beneficial medical uses of peptides for the treatment of various diseases. And next slide, next click, please. And Daryl recently sent me a couple of weeks ago this email. He's struggling at the moment, perhaps in the last stages of his disease, and he said, "Good morning, good young chappie," and anyone that calls me young has got to be a good bloke. Bet you're as happy as I am today. We made the finals. Could this be the Baby Bombers? We looked damn good yesterday. Let's hope, Daz. Next slide, please. And this is another of our patients, one who we hoped on the basis of our scans that we'd possibly cured. She had very extensive disease, it responded extremely well to PRRT with just a small amount of residual disease in her pancreas that Ben Thompson actually removed. Ben can't be with us today, but did the surgery, and for a number of years she remained disease-free, and she sent me an email, next click, saying, and she told me I could use her name, Kristen, also known as Nana, sending you news of our first beautiful granddaughter. This was my dream to have this moment in my life, and I can't wait to hold her in my arms. Thank you, and you know why. And this is the result of that new grandchild, and she went off. And unfortunately, Kristen developed a brain metastasis, which is now being treated and under good control. And she sent me an email yesterday wishing us well for the 25th anniversary. Next slide. So in many areas of cancer, we look at survival curves and response rates. And the things that I think are really important in what we've done is to really much focus on the quality of life as much as the duration of life. And so it's the stories that my patients and our patients tell us that have brought me most joy over these last 25 years. A 16-year-old girl with high blood pressure and headaches related to a tumour called pheochromocytoma in her adrenal gland, who spent her 21st birthday in Greece with her sister. A 17-year-old girl with masculinizing neuroendocrine tumour gave her acne, her hair to fall out and become quite muscular, who went to her formal looking gorgeous after we turned off that excess hormone secretion. A 25-year-old man who didn't need treatment for 18 months and allowed him to establish his business, which he was forming. A 44-year-old man who built a home for his family after the devastation of the Christchurch earthquake and appeared on Grand Designs New Zealand. As an amateur or frustrated architect, I also appeared on that program, and it was one of the joys of my life. And he's left an unbelievable legacy for his family. A 75-year-old actress who won an award after returning to stage after feeling the best she had in 7 years. And I know Professor Michael knows this patient extremely well. And a 60-year-old with carcinoid who was the third patient to receive indium-111 octreotide in 1996, the first to get infusional chemotherapy with lutetium octreotate in 1999, and the second patient to receive lutetium 77 in 2005. He remained well for 12 years and 18 doses of therapy, living long enough to coach a team of his grandson, who he would otherwise never have known to a premiership. And I remember going to his funeral, and most of the photos that they showed at the funeral were in the last 12 years of his life. And finally, a 50-year-old cardiologist who rode the Tour of France and founded the Unicorn Foundation in New Zealand. Next slide, please. So this is that same gentleman's slides. And as you can see, pretty dramatic improvement in his scans from before treatment to after treatment. But the picture that means most to me is the next one, which is him, as I said, riding behind the Tour de France. He's had an incredibly good quality of life because of the effects of his treatment. But he's also had a huge impact in his home country of New Zealand, where as part of the Unicorn Foundation New Zealand, he was able to establish access to GAT8 PET-CT, and more recently, they've achieved funding for Prrt in New Zealand on the strength of data that was largely acquired at Peter Mac over the years in the New Zealand patients that we've treated now for over 15 years. New slide. So if you take nothing else away from today, I hope you'll take this thought, which I think is as relevant now as it was 2000 years ago, was written by Horace. Happy the man and happy he alone, who can call today his own. He who secure within can say, tomorrow do thy worst, for I've lived today. Next slide. I did promise Simone that I would give a historical background to the Prrt program. In fact, my journey with theranostics began more than 25 years ago when I was a fellow at the University of Michigan. And I really liked this attachment because I had three roles there. One was general nuclear medicine, one was being attached in an internal medicine job to the endocrine tumor, and the last was attachment to the cardiology unit where I did cardiac PET research and teaching the cardiac fellows. Next click. One of the reasons I got particularly interested in PET was the only department in, or only area of the nuclear medicine department that actually had a window, and people will realise that the Peter Mac nuclear medicine department's on the 5th floor, and windows rather than being in the basement was a very high priority in the design process for me. Next. It was great to be at University of Michigan because one of the pioneers of early theranostics, Bill Bywalders, was the chief just before I arrived there. He'd retired shortly before then, but he developed MIBG and got his chemist, or had the idea of MIBG and got the chemist there. Next, click Don Whelan to produce MIBG. And the next slide shows the very first example of theranostics that I saw in Michigan in the endocrine clinic. This was a young man, a short order chef from Detroit, who had widespread metastatic pheochromocytoma, and this is an MIBG scan that was acquired a number of years actually before I arrived in Michigan, where he'd been one of the first patients treated with this therapy, and his blood pressure had been completely controlled, and he'd had a very good quality of life in that time, and this for me was an eye-opener. Next slide. So I started, I guess, with that image, my journey from being interested in cardiology to oncology. In fact, my thesis was in the study of the heart. But even from an early stage of my research career, I was interested in novel radiopharmaceuticals against receptors and on the impact of hormones on the function of the body, particularly on the heart. Next slide. And so this quote from Douglas Adams, I rarely end up where I was intending to go, but often end up somewhere that I needed to be. Next slide. And one of those places was Peter Mac, a friend of mine who was became the director of radiology, invited me to come to Peter Mac. And when I arrived there, we started to see some of these patients with metastatic neuroendocrine tumours. And with the help of Peter Yu, who's still with the team, an incredibly important part of our therapeutic program, we introduced iodine 131 MIBG for the treatment of metastatic pheochromocytoma and paraganglioma in adults and in neuroblastoma in children. And the results really spoke for themselves, as we could see tumours really melting away before our eyes, and patients' disease symptoms are also remitting. Next slide. There was a report a number of years earlier than that MIBG might be helpful for the treatment of carcinoid tumours. And when we started to get some carcinoid tumour patients, we tried that again, MIBG, but it really just didn't work in our hands in neuroendocrine tumours of the gastrointestinal tract. Next. But we didn't give up. We showed courage in going from failure to failure without losing enthusiasm. Next slide. Serendipity often plays a hand in medicine. About that time, I'd actually been elected into the New York Academy of Sciences by my boss, or nominated by my boss in Michigan on the strength of the cardiac research that I'd done. But as part of being a member of that society, you get an annual. And in the first annual that I got, I opened it and read with interest this case of radiotherapy with a radio-labeled somatostatin analog, indium DTPA octreotide, which was the first form of PRRT. If you look at the complex graph on the right-hand side, this patient received 4 cycles. Next one, thanks, Jai. 4 cycles of treatment over a several-month period, and then another 2 cycles several months later. And this really had a very minor effect on the growth of the tumour. It continued to grow for a period of time before turning the corner and stabilising. But more impressive and more important was the demonstration that the hormones that this tumour was secreting, which was causing most of the patient's problems, went down quite dramatically with the first course of treatment and responded again to retreatment. And this was particularly relevant to me because my cardiac stress nurse happened to have one of these neuroendocrine tumours that was actively secreting a hormone. Next slide, please. And, I went on the basis of this and spoke to our Chief Medical Officer, Rob Grogan, and said, could we try and get this treatment into Peter Mac? And he said that would be fine under compassionate use criteria. And I wrote to Eric Krenning. We used to write letters in those days before the internet, but he wrote back and sent some white powder in the mail that we subsequently labelled. And we took the risk because we trusted in the evidence that we could see there, and that brought us great joy. Next slide. And that set up a relationship with these gentlemen from Europe. Eric Krenning in particular has been a lifelong friend for me since that time. Eric and Dick Queckerboom, who unfortunately died a number of years ago, was also a great friend. And they've given us great support and great wisdom over the years. Next slide. Those gentlemen developed the science from being able to image at a cellular level the expression of the target for PRRT, to translating that into scanning of individual patients, and then finally applying that to the use for treatment in terms of radionuclide therapy, which we now call PRRT. We started that in September 1996, as you've heard, and we also, at the same time, started our PET program at that same month, almost a week apart. We've passed the first PRRT day. We're about a week away from the first PET scan day. But the patient I spoke about, my cardiac stress nurse, these are her scans actually, where we showed that there was intense uptake in her liver tumours, and that the tumours had different levels of shrinkage depending on how intense they were. And in fact, and unfortunately, one of the deposits in her liver didn't have any uptake at all. And it started to grow, and we put her onto the PET scanner and showed, in fact, that was a site of disease that lacked the receptor but was very actively growing. And so that actually very much in the early stages emphasised the need for characterising the expression of these targets in tumour deposits. Next, thanks. So synergy and serendipity often play a big part in medical and scientific advances, as Julie Bishop once said. Next slide. And we started this idea of doing dual tracer imaging, using 2 tracers to define 3 separate populations of cells, a population of cells represented by green in the lower grade tumours, which have somatostatin receptor expression that lack the use of glucose, which is a marker of more aggressive disease behaviour. And these are generally suitable for PRRT as long as there's evidence that they're producing hormones that can't be controlled by other means, or they start growing. At the other end of the spectrum, the very aggressive diseases, which become glucose avid, are positive on FTG, but lack the somatostatin receptor. Clearly, they're unsuitable for PRRT because they lack the target. But the most important group, and the ones that we get on and treat much more aggressively these days, is where both targets or both features are present, because the cells that sit in that area are both more sensitive to radiation, but also more likely to progress. And this has now been adopted around the world and codified by our friends at the Royal North Shore by something called a PETNet score, which scores the ones that are green as a P1 and the ones that are red as a P5 and the ones in the orange as P3 to P4. Next slide, please. And so the colours we've chosen deliberately. Red, don't think about PRRT. Green, you can go at any time as long as it's safe to go. The orange, hurry, you haven't got much time. The other thing, and I'm not a big user of social media. I'm sad to say, Jai. I know that the communications people are very keen on Twitter and various other Facebook pages. I know that early on we got some criticism because we weren't treating people when their scans were positive. And the reason for that was, if the tumour isn't growing and it isn't causing symptom, we can't make someone better. We can only cause them side effects. And so we've adopted a program of following patients with serial imaging in the absence of symptoms until there's clear evidence that their tumours are progressing. And so sometimes this can take many years. These tumours are very, very slowly growing and well controlled by other therapies. Next slide, thanks. So we've gone through various iterations of treatment over the years. We've been continuing to try and improve the effectiveness of our treatment. We moved from high-dose indium to a treatment called yttrium, and then to lutetium, and we've added chemotherapy along the way to that algorithm. Thanks, Jay. And these patients were treated using compassionate use criteria, as I said, which were for unproven therapies. Most of them had advanced disease, and many of them had failed multiple lines of therapy before we got to see them. And many indeed would have been excluded from clinical trials just based on very poor clinical state. Next. One of the things of which we're most proud is pioneering what we call peptide receptor radionuclide therapy. We were the first to combine this therapy with radiosensitizing chemotherapy, and there are now a number of trials being developed around the world to further evaluate and test this therapy. Next slide. We've also made it clear that the importance of doing post-treatment imaging to demonstrate the distribution of disease, the retention of the tracer within sites of disease. And we find this incredibly helpful for also displaying to our patients how their treatment is going by seeing less sites of disease apparent on follow-up imaging. Next, thanks. The other thing that we recognised very early on, because this is a rare tumour, we needed to get engaged with the broader community, not only within Australia, but within the world. Soon after, a couple of years after we started our program, my friend Harvey Turner began a program of Prrt at Fremantle Hospital in Western Australia. In those early years, we set up a cooperative group, next please, to try and get a number of centres involved in Prrt around and other forms of radionuclide therapy. And we had some debate about what that group should be called. And I said, I'm not particularly fussed about what the group is called, but it's such an important process to advance radionuclide therapy in this country, and one that that I hope will also have international ramifications. Next. And indeed, you know, at that time, Novartis were looking at doing a trial in yttrium-90, and that became a reality that I think 4 sites in Australia became involved in what was called the yttrium etotretinoin trial, which was subsequently published in the Journal of Clinical Oncology 10 years later. Next slide, please. The other thing that we've been very active in is developing the diagnostic tools. I was involved in bringing Octreoscan, which is the indium octreotide scan, into Australia. We were one of the first sites to develop institute combined hybrid imaging with SPECT-CT, and we were the first site to do gallium octreotate scanning in Australia. And although this spectrum represents about 15 years of development in the field, the 2 scans on the left and the right are the same patient a couple of days apart, scanned by both methodologies. And you can see the dramatic clinical improvement in detection of disease by the new technology. Next slide, thanks. And we looked at that in terms of what the management impact was, and found that in over 50% of cases, we had a significant change on treatment, and that subsequently has led to this treatment being reimbursed as the preferred method for staging and following patients with neuroendocrine cancer. Next. And it certainly is the winner in what I call the lumpology stakes, the ability to detect sites of disease. Next slide. In terms of the therapeutic radionuclides, as I mentioned, we started with indium-111 DTPA octreotide. The idea here is that you have a target, which is like a lock, the peptide, which is like a key, the linker, which is like a key ring, and a radionuclide, which is the dangly bit that you have on your keys. And the next iteration of that is lutetium-177 DOTA octreotate, which some people call DOTA treatment, some people call dotatate. I call it lutate because it's the dangly bit and the key that makes keys interesting. And the target of that is somatostatin subclass 2 receptor. Next slide, please. I mentioned the ability to localize disease, the SPECT-CT, the hybrid imaging, to understand this. And I sometimes say to the patients that we use deliberately the radar map. Where it's red, it's a thunderstorm. Where it's green, it's a heavy rain. When it's blue, there's a little bit of drizzle. Next slide. What the CT does, it adds the context, the geographical context. Where is this happening? Next slide. This also allows us to look at or to develop a method of dosimetry. So one of our visiting fellows from Canada developed a method that's been further advanced by our physicist, Price Jackson, has become an incredibly vital part of our program, the ability to measure the dose of radiation delivered, in this case where we're getting very high radiation doses to the tumour, particularly on the first cycle. We can see the dramatic response during treatment, and this allowed us to stop treatment in this particular patient, and this become a part of our research and clinical program that we use not only for neuroendocrine tumours but now for prostate cancer and pheochromocytoma treated with MIBG and other diseases as well. Move on, thanks. But the images are really important to the patients. Our ability to show the uptake in the tumour and the progressive and sometimes slow regression of tumour over time is incredibly useful for our patients. Next slide. And we can also monitor this with blood tests where we can see the course of treatment and response to previous treatments. And again, this is really reassuring to patients to see that their tumours are responding. Next slide. This is what we call a Kaplan-Meier curve. These are something that the scientists love, but I tend to hate, because everyone above the line represents a patient who's died, and everyone below the line is still alive, but we don't know what the quality of their life is. And as I pointed out, much of what we're trying to do is not only prolong life, but improve the quality of life. But nevertheless, the median survival in our first group of patients treated with this lutetium Prrt was substantially better than most of the described literature for the survival of such patients. New slide. And when we looked at the worst prognosis patients, the ones who had that orange phenotype, the combination of both FDG and somatostatin receptor expressing disease, Jai, when we compared the progression-free survival, how long it took for their tumours to grow, it was substantially higher than most of the retrospective series in similar patients. And we think that we probably had at least as poor a prognostic group as any of those particular trials. Next slide. So on the basis of that, we've moved to treating more aggressive tumours with first-line peptide receptor chemoradionuclide therapy. And this is actually a GP from the country who actually elected not to have the chemotherapy part of the regimen, but she had very extensive disease in her pancreas, invading the vessels that led from the pancreas into the liver, and had a very high-grade tumour with proliferation in roughly 50% of her tumours. More typically, low-grade neuroendocrine tumours have 1 to 2% of their cells that are actively dividing. Next slide, please. And as you can see, she had a very dramatic response, and I actually saw her just a few weeks ago. She's now 6 years out from her treatment and has only a really very small tumour in her pancreas. Next slide, please. Grace Kong, who you'll hear from later, led a trial at Peter Mac looking at the outcomes in these G3, the highest grade neuroendocrine neoplasia, showing a very high response rate and good disease control rate, which has subsequently been validated in studies in Germany and in Scandinavia. Next, please. And this also shows that even up to quite high grades of neuroendocrine tumour, very encouraging control rates can be achieved. Next slide. The last thing, I guess, that we started, I think, with indium, which has a very short range, can treat individual cells. We went then to yttrium, which had a very long path length of around 10 centimetres, so could treat very big lesions, but had some toxicity to the kidneys and marrow. Next slide. And then went to lutetium, which was most of the data I showed you before. Next slide, please. Again, Grace led a very nice study looking at going back to that yttrium where there were big deposits. Next, please. Where there are this very large tumours, the large crossfire effect that we get is more effective at treating those tumours. And you can see the dramatic responses on both the scans and the CTs in this case. Next slide. And in that particular population, we had the best overall survival that we've seen, the greatest shrinkage of tumours that we saw, and a very high PET response as well. Next slide, please. And in these kinds of patients with very bulky disease, by using aggressive treatment and retreating at recrudescence, we can get a very long duration of disease control. Unfortunately, eventually the tumours do tend to become resistant to PRRT. Next slide. But the patient whose images you saw again, I want to come back to the importance of what we're doing to the quality of life. This patient, whose name was also Rodney, sent me many emails over the years that I looked after him of all the adventures he had around the world. Next slide. When he came to me, he felt like he was looking over the edge of the Grand Canyon, and he said subsequently that he felt he knew what the final destination would be, but he was very glad that he took the alternative route down the mule trail rather than off the edge. Next slide, please. So where have our patients come from? Well, they've come from all over Victoria. In the early years, they came from New South Wales and Adelaide and from the border areas to us. Next. But we've also had patients coming to us from around the world. And this is quite an old graph, but this has all been by word of mouth referral. Next slide, please. The reason we had to close our borders is because we had very limited funding to do this. Although we tried very hard to get a secure form of funding, the light has been red for a long time. And with that, I particularly want to acknowledge the efforts of Neuroendocrine Cancer Australia in trying to change the lights to green, so that, like New Zealand, very soon, hopefully, we will have funding for PRRT widely available in Australia. But with that, I just wanted to finish by thanking so much all of the team that have been involved in this over the last 25 years. As I said, it was a pretty lonely place when I started PRRT that long ago. No one was interested in neuroendocrine tumours, but now we have a wonderful team of nurses, technologists, physicists, and clinicians who are wonderfully engaged in the field, who are doing great research and delivering fantastic service to our patients. And added to that, we have great support of the quality of life through dietitians and social workers. It really is the crux of a multidisciplinary team in a place like Peter Mac that can focus not on the scan, not on survival, but on quality of life. And with that, I'd like to thank everyone for their support over the last 25 years, and really excited about the future of the department. Even though I'll be leaving the clinical service, I'll be vitally interested in how it develops over coming years. So thank you.
Thank you so much, Rod, and thank you for, once again, an incredible presentation. And I know that, yes, thank you for doing the history, because I always nerdily find it very, very fascinating. And thank you to you and to the team. And I look forward to reiterating that later in the presentation in the next hour. But as you said, you know, it's the stories behind the scan. And with that, I'd like to introduce a person who is one of those stories behind the scan. And it's one of our wonderful neuroendocrine tumour patients, Ross Flanigan, who will be sharing his story with the treatment of PRRT.
Thank you, Simone, and thank you, Rod. It was very interesting listening to the history behind PRRT. Look, my story basically started 5 years ago, back in 2016, with my first symptoms that I had was basically bouts of sweating and feeling very listless and weak. And these were very rare events. And they predominantly, the first time I ever had that was on a golf course. And I really originally thought that I was just dehydrating. I wasn't drinking enough water and so forth, but I did have a craving for food during those times. So I went to my doctor and had some blood tests and so forth. They really showed nothing originally. He said, look, if it continues, please come and see me. So I come back probably about 3 months later because I'd had other bouts of this sweating and feeling very weak and so forth. He took some blood tests. It showed that my blood sugar levels were low. So he then referred me to an endocrinologist. That endocrinologist wanted me to get some blood tests of times when I wasn't feeling well, which was a bit difficult when you're on the 15th hole of a golf course, I can assure you. But anyhow, I eventually got some blood tests back to her really early in the morning. I had some early morning issues where I wasn't feeling that well, and it showed my blood sugar levels were dropping. So she then wanted me to do a 72-hour fast, which I was sent to the Austin Hospital. And it took a while for me to get into that hospital, and I was continuing to having more and more bouts of these sweating and so forth. And because it was just a public hospital and it wasn't elective, it was elective, so I couldn't get in quick enough. But it took another 2 months before I got there. And they started this 72-hour fast for me, and I only lasted about 8 hours, and my blood sugar levels had dropped too low. Therefore, I was required to eat straight away. They then did a number of subsequent tests on me, scans and blood tests and so forth. They spoke about, asked whether I'd had issues with my liver. I'd never had any issues with my liver in my life. And they said that my readings had come back abnormal. And I went and had a biopsy of my liver. And it identified from there that I had neuroendocrine tumours, a primary tumour in my pancreas that has spread to my liver, and they were insulomas. Therefore, they were continually releasing insulin. Things were a bit dicey back then because they then sort of got me into the Olivia Newton-John Cancer Centre to have a dose of chemo intravenously because they were concerned that I would have liver failure if I didn't have it straight away. From there, of course, my lovely wife did a lot of research, and we made contact with Simone. At that stage was the Unicorn Foundation, and she was instrumental in getting me into Peter Mac to meet up with Dr. Michael and Grace Chong and also Rod Hicks. And from there, I transferred my treatment across to Peter Mac because of the Prrt treatment that was offered there. And from there, I've actually now had 12 treatments in the past 4 years. I originally had 5 treatments pretty close together, about every 6 weeks. I think my last treatment might have been 10 weeks from the 4th one. And from there, I've had another 7 treatments. I'm continually scanned. I continually get blood tests to make sure that the tumours are reducing and not active. And every time they become active, back I go again and have more treatment. And it's been fantastic. Look, you know, I'm very blessed to have had this type of treatment available to me. I do have some side effects when I'm going through the treatment, and even with at times where Dr. Michael's had me on capecitabine tablets, that's made it a little bit more difficult to tolerate. But overall, I'm fine. I've had 3 treatments this year. I had treatments back in April, June, and of course now just recently in August. I've now got 3 months off before anyone wants to see me, which is great. And I'll go back through scans again. But I couldn't be more thankful to the Peter Mac team, to Prrt, and the research that's been done around that. It's been fantastic for me. And I really do appreciate all the support that I get from the Peter Mac team. You basically saved my life. And without that treatment of being available for me, I don't think I'd be here talking to you today in the condition that I was when I first got diagnosed. And that was something that I know that Simone spoke about and so forth, was the fact that they need to diagnose this type of tumours much quicker. It basically took me 12 months from when I had my first ever symptoms before I was fully diagnosed. And to the amazement of my doctor and to the amazement of even the endocrinologist, because even when I went to see her, she thought I might have had a benign tumour on my pancreas, which was releasing insulin, and they might have trouble finding it. But they didn't have any trouble finding it when I first got in there, because it was about 70% of my liver had tumours in it when I first got diagnosed. So thank you to the Peter Mac team. Thank you to you, Rod, for all your work you've done over the 25 years with Prrt. For people like me, we are gratefully thankful for that we've got this not hospital in Australia, we've got it in Melbourne. So thank you to everyone. That's basically my story. And I hope to have a long association with Peter Mac until a cure is found. So thank you.
I'd like to know what your golf handicap is now, Rod.
If I could get out on the golf course a bit more often, I'd hope to have a bit lower, Rod, but it's currently sitting at 16.
Very good.
Yes, I think that's probably not your health there, Ross. It's probably a lockdown thing, unfortunately, with the lack of golfing. But
certainly lockdown.
Yeah, but thank you so much, Ross. And I do remember that call with Carol Ann, our beautiful and your beautiful advocate, who is a champion advocate. And most of our carers are these champion advocates for our patients. And I remember that call very vividly, and I'm so pleased that we were able to assist you and that we're here today to celebrate you and to celebrate the team at Peter Mac. So thank you, Ross. So we were going to take a quick break, but we think we don't want to lose the momentum of such a wonderful event. So we will actually keep going. And what we'll be doing now in the next hour is Grace will be doing a bit of a presentation on the latest research in clinical trials in PRT, and we've followed on by the mock MDT with a couple of case studies there as well, which we always know patients really love to see how are the decisions made about their treatment, and these MDTs are a great way to see how the multidisciplinary decisions are made. So this is therefore my pleasure to welcome Associate Professor Grace Kong. Grace is a nuclear medicine physician at Peter Mac and a clinical associate professor at the University of Melbourne and supported with MacCallum Cancer Department of Oncology and is an integral part of the NeuroEndocrine clinic there. And just as a reminder for everybody to be asking questions through Menti, and there is the code there too. So welcome, Grace, and we look forward to hearing from you.
Great. Thank you very much, Simone, for the very kind introduction. And I'll just get my slides up. Okay, here we go. So thank you, Simone, and thank you for the opportunity to participate in this very, very special event today. So my topic is on the latest clinical research and trials, with a particular focus on what is available for the patients in Australia currently. Whoops, going backwards. Okay. Now, to begin, I think it will be helpful to summarize and to remind everyone what the different phases of clinical trials actually mean. So a phase 1 trial is designed to study a new intervention, usually in a small group of patients, focusing on the safety of the product and also to determine the safe dose range, if applicable. Now, once an intervention has been shown to be safe, then a phase 2 trial is then done to test an intervention in a larger group of patients, usually in the hundreds, to focus on the efficacy, meaning how well it works, and of course, to further test the safety profile. Now, once an intervention is proven to be safe and effective, then the phase 3 clinical trial is designed to compare the intervention to another standard or experimental interventions, usually in a much larger group of patients, typically in the hundreds of thousands, as well as to further monitor the adverse events. Now, a stage 4 clinical trial is usually done after an intervention has been marketed to further monitor the effectiveness and the side effects with wider spread use over a longer period of time. So in terms of NETs, as you know, there has been a steady development of therapies over the decades. If we concentrate on the earlier part of the graph, most of the initial focus was to look at older forms of chemotherapy and also to establish the use of somatostatin analogs like lanreotide and octreotide. As we now know, this has now become a well-established, almost standard of care treatment for most patients with NETs. It's not really until the last 12 years or so that we have started seeing clinical trial data coming out, looking at other treatment options, such as everolimus, sunitinib, telotristat. And with PRRT, the first randomized controlled trial, phase 3, was published in 2017. So clearly we need to find more safe and effective treatment options for patients with NET, and therefore it's important to have ongoing phase 1 and phase 2 trials. More importantly, we also need more information to guide us in terms of which particular treatment to use first, which we call sequencing of treatments. And therefore, it is important to have a comparative trial and larger randomized control phase 3 trials. Now, here's a table really summarizing the 7 key randomized controlled trials published for the treatment of patients with advanced NETs. As you can see from the year 2009 to 2017, these treatments have been shown to be more effective than the corresponding control arms, such as octreotide from the PROMIT study, lanreotide, the use of everolimus in several Radian studies, sunitinib, and as mentioned, the NETA-1 trial in 2017 showing the effectiveness of Prrt over the control arm, which was high-dose octreotide 60 milligrams. But I think clearly we do need to have more randomized controlled trials for patients with NET. So what is the current status then in 2021, particularly focusing on what's available in Australia at the moment? Now, firstly, I would like to highlight that there are 2 centers of excellences that is recognized by the European Neuroendocrine Tumor Society. Peter MacCallum Cancer Centre was accredited in 2018, and the Royal North Shore Hospital in Sydney shortly after that. The reason I'm mentioning this is because I think it really demonstrates that there is the international recognition of a very high quality multidisciplinary approach that we have developed in Australia for treating patients with neuroendocrine tumor, not only from the clinical front, but also in the research perspective. I must also mention that in other states, there are also state-based NET centers who also have very dedicated clinicians providing high quality care to patients with NET. But we have to remember that where we are now is really based on many years of hard work and experience, and particularly with a huge contribution with incredible vision and innovation by Rod and his team over the last 25 years. Now, with that in context, I think there is really now a very strong foundation in Australia now, and there is a real focus to develop and participate in clinical trials, bringing them to patients in Australia. Now, currently, there are actually 12 prospective clinical trials that are available in this country. Looking at this graph, you can see that most of these studies, 6 of them are Australian multi-center trials. Again, that really highlights the collaborative effort that we have in this country for doing trials for these patients. Particularly, I think it's very important for uncommon malignancies like neuroendocrine tumor. There are 3 studies that are part of an international multi-center trials, and also 3 studies that are being performed in institutional departments. Interestingly, and I think it's important to point out that 8 of these studies have been ongoing from previous years, but importantly, 4 studies are actually relatively new since 2021. So again, I think that really highlights the current momentum, the ability, and also the importance of doing prospective trials for patients in Australia with NETs. Out of these 12 current trials, it also covers a fairly wide range of different aspects in terms of NET management. Now, that includes a variety of different management paradigms, such as looking at combination therapies. There are trials looking at different chemotherapy regimens, looking at biomarkers. There are comparative trials, so comparing one treatment to the other, and also discovering new approaches and new diagnostic agents. So in the next 15 minutes or so, I would like to provide you all with just an overview and a summary of the 212 prospective NET trials currently running in Australia, as well as highlighting some of the new trials that have recently opened in 2021. So as mentioned, there are 6 current Australian multi-center studies, and many of these have been ongoing since the previous years. The first one I'd like to mention is called the ControlNet study. So this is a combination therapy combining chemotherapy using capecitabine temozolomide together with lutetium dotatate PRRT. Patients with pancreatic NET will have this combination therapy compared to CAPTAM chemotherapy alone, and patients with midgut NET will have the combination therapy versus PRRT alone. Now, this is actually finished in its recruitment and currently in the follow-up phase, but the interim results have been presented recently in big international oncology conferences. The second study I'd like to mention is called the NET study, which is using a sort of fairly new combination of chemotherapy regimen, nab-paclitaxel together with carboplatin to treat patients with highly aggressive or high-grade neuroendocrine carcinomas. This is also nearing towards the end of the recruitment phase right now, so we're looking forward to seeing the results when it comes through. The third study to mention is called the Sanguis Trial. It is to look at the potential role of circulating DNA, which is taken via a blood sample, in the management of patients with pancreatic NET. It is to evaluate whether the circulating DNA can actually be found to be associated with gene mutations, and also is it predictive of the disease course for 100 patients. The Planet Registry. This is really pioneered by the NeuroEndocrine Cancer Australia group, together with collaborating with the key NET centers in Australia, as well as the University of Melbourne. So this is a big study, a very important one. It is an observational, multi-center, non-interventional program to register patients diagnosed with neuroendocrine neoplasms and to monitor the patterns of care in Australian hospital, like in a real world setting. Associated with this, as Simone had mentioned before, is an app that the patient can actually record their quality of life parameters, as well as to record their diarrhea patterns by a Bristol stool scale. And so this project is currently in progress. The next study is highlighted with a star and highlighted in blue. It's called the Gotham Study because it is a relatively new study that I would like to elaborate on a little bit more later on. But briefly, it is looking at combining an immunotherapy agent called avelumab with PRRT or radiotherapy in patients with metastatic Merkel cell carcinoma. The next study is also a relatively new one called DISCO. It is a diagnostic study looking at a new PET imaging agent called copper sartate. Now, the next three studies are actually part of international multi-center trials, and they're all very important. The first study listed here is the JR11 study, looking at the use of this radiopharmaceutical as a form of PRRT called lutetium OPS201. So it attaches basically to somatostatin receptors, but OPS201 is a somatostatin receptor antagonist, so it binds onto the somatostatin receptor in a slightly different way, and can be potentially more effective. Now, this particular treatment or trial has actually finished in its recruitment right now and currently in the follow-up phase. The second study listed here is called COMPETE, and I think it's also a very, very important study because this is a big phase 3 comparative trial, really comparing PRRT with everolimus in patients with grade 1 and 2 gastroenteropancreatic neuroendocrine tumors for 300 patients. Now, this trial is also nearing towards the end of recruitment, which is very encouraging. Unfortunately, from Australia's perspective, there's been a pause of patient recruitment because of the inability to obtain the radiopharmaceutical during the pandemic. But hopefully that will be rectified quite soon and that we can restart the recruitment in Australia. The third trial here, RadioAssist, is looking at a particular treatment using endoscopic ultrasound-guided radiofrequency ablation for treating patients with localized cystic and including neuroendocrine tumors of the pancreas, which the Royal Melbourne Hospital is participating in. Now, the next three studies really is a summary of the current institutional prospective trials basically running at Peter Mac at the moment. 10116, analysis of imaging phenotypes and genotypes in NET patients undergoing PRRT, led by Professor Hicks. For this particular trial, we're looking at different responses. So we know that some patients actually respond dramatically well very early to PRRT. However, some patients actually don't respond as well and actually progress fairly quickly after PRRT, despite the very high uptake on the initial scan. And the mechanisms of that is unclear at the moment. So hopefully with this particular trial will provide us some insights into whether there are any genomic changes that may be associated with either of these groups for patients with radiosensitive disease or patients with radioresistant disease. The next trial is called PALUNET, and again, I would like to elaborate on that a little bit later on, but it is a phase 1 study, so an early stage study, but looking at a very novel combination of a PARP inhibitor combining with lutetium dotatate PRRT treatment. Now, the third study listed here, blood sample collection from NET patients treated with PRRT for future blood disease research. This is a very important concept, I think. We know that patients who have PRRT can have a very good response, but a very small proportion of patients may develop a blood disorder later on. And sometimes the blood disorder can be difficult to treat, such as developing MDS or AML. And again, we don't really understand the mechanism behind that at the moment. So by doing this particular study where we are aiming to collect serial blood samples before, during, and after PRRT, may allow us to perform detailed genetic and molecular analysis in the future to better understand the mechanism of this complication and hopefully to reduce its complication in the future as well. I must highlight, however, that there are, sorry, lost the slides there, Jai. Just quickly go back to the latest slide. Oh, sorry, before that. Before that as well. Bit more. Rewind. Yep. Okay, thank you. So I must highlight that there are several other potential prospective trials that are currently in planning, and I'm sure that there are several retrospective studies that are being performed in different institutions as well. Okay, so moving on. Can't really advance my slide. Sorry about the technical issues. Okay, I'll start from there. Good. So I would like to now just to let you know a bit more about these three particular trials, which is called DISCO, Gotham, and PARLONET. Hopefully I can advance now. Yep. Okay. So the first trial that I'd like to talk to you about is called the DISCO trial. So it is a prospective multi-center study running at Peter Mac, Royal North Shore Hospital and the Royal Adelaide Hospital, which is industry sponsored, looking at a particular agent called copper sartate. These are for patients with suspected or known gastroenteral pancreatic NET who are also having a standard of care GATTATE PET-CT within 4 weeks. The main aim of this trial is to compare the diagnostic performance of this new agent called copper sartate compared to gallium dotatate, which is the conventional imaging modality, in 63 patients. Okay, so what is copper sartate? Like gallium dotatate, copper sartate is a PET tracer, which can image neuroendocrine tumors through somatostatin receptors. But the main difference is that copper 64 has a much longer half-life than gallium, which means that the copper 64 can stay in the body a little bit longer before dissipating. So this basically enables longer imaging time, so imaging can be done the next day, and it may improve lesion detection. So for small lesions, it may show up brighter on delayed images. It may also help to potentially calculate dosimetry for PRRT, and what that means is potentially it can help us calculate how much PRRT to give, tailored to the individual patient. And this is based on prior evidence that was published in 2009 by the team at Peter Mac, led by Rod, where we performed a first-in-human study at Peter Mac for 10 patients who received the copper sartate injection, and showing that it was a safe modality and the quality of the images were very good. So the objective of this particular study is to perform a larger phase 2 multi-center trial to compare the diagnostic performance between this new agent versus the conventional agent. And hopefully it may provide an alternative modality or even a better modality in the future to diagnose or to find NET lesions. Okay, the next study to talk about is the Gotham study. So this is also a prospective multi-center Australian trial that is sponsored by the Melanoma and Skin Cancer Trials Limited and funded by the NHMRC grant. So it is really looking at PRRT or external beam radiation in combination with immunotherapy called avelumab in patients with metastatic Merkel cell carcinoma. It is to evaluate the effectiveness of its combination treatment, side effects, as well as associated with biomarker studies in 50 patients. So why are we doing this? Well, we know that patients with Merkel cell carcinoma can respond to avelumab, the immunotherapy, but many of patients actually develop resistance within 1 year. So it's not a very durable treatment. And therefore, new treatments are needed to improve the patient's outcome. Now, we know that Merkel cell carcinoma, they are usually very radiosensitive tumors. So that provides a rationale to combine radiation, either with PRRT or external beam radiation with immunotherapy. And hopefully this will lead on to an improved outcome for these patients who otherwise will have very limited treatment options. Now, the next trial to let you know about is called the PALUNET trial. So this is a prospective phase 1 single center study that's being performed at Peter MacCallum Cancer Center. And this is sponsored by Peter Mac and funded by the NetRF grant, with the talazoparib, the PARP inhibitor, being supplied by Visa. So the treatment here is really to combine PRRT with talazoparib, which is a PARP inhibitor, for patients with grade 2 neuroendocrine tumors with progressive disease. And the main aim of this phase 1 study is to test the safety and tolerability, define the right dose of talazoparib in this combination treatment, as well as testing the effectiveness in 24 patients. So just briefly, why do we want to combine PRRT with a PARP inhibitor? Well, we know that cells are actually made up of DNA, and DNA are basically made up of 2 strands that's formed through a helix bound together. With PRRT, the main aim of the radiation is to induce a double-stranded DNA break, meaning trying to break both strands of the DNA. When that happens, the cell actually will not survive, and it will promote cell death of the NET cancer. But in reality, many of the break from PRRT results in a single-stranded DNA break, which is not ideal because there is a substance in your body called PARP. So PARP1 can actually come in to repair the single DNA break, which is not what we want for cancer treatment. So the particular study drug, which is called a PARP inhibitor, actually stops the natural PARP1 from working. So it prevents the repair of the single-stranded DNA break. And in fact, it will promote the 2 strands to break as well. So it actually promotes cell death. So by adding a PARP inhibitor to PRRT, it may further promote NET cell death. Now, this is a fairly novel concept supported by preclinical data that has been published by the team at Peter Mac, led by Rod. And so this is actually a first phase 1 study looking at this novel combination in human. And the aim is to further enhance PRRT efficacy in NET patients with progressive disease. And hopefully the results will guide the design of a future phase 2 trial, hopefully PRRT alone versus PRRT plus a PARP inhibitor in the future. Now, there is one last final trial that I would like to mention, which is a potential international prospective trial, which is currently not active as yet, but hopefully we can bring it to the Australian patients later on in 2021. And this is called the COMPOSE study. It is a phase 3 prospective randomized controlled multi-center trial, which is industry sponsored, but really for patients with grade 2 or grade 3 gastroenteropancreatic NET, which is for high-grade tumors. And there are 2 active treatment arms. So they're comparing PRRT using lutetium edotrietide versus standard of care by physician choice, which can either be chemotherapy using Kaplan or FOLFOX or everolimus. So I think this is a really clinically important study, answering a very clinically important question. The primary objective of this trial is progression-free survival. They're hoping to recruit 202 patients internationally. International recruitment is hopefully going to start later on in the year. And Peter Mac will be a participating site, hopefully later on. And I believe another Australian site will be participating as well. And in Peter Mac, we've been very, very heavily involved with the trial concept and the design of this particular COMPOSE trial. So finally, 2021 and beyond, I hope I have conveyed the message across that there is an increasing number of prospective trials in Australia and definitely worldwide. And hopefully they will provide very robust data in terms of guiding us how to manage and treat patients with neuroendocrine tumors. There is now a clear focus on performing multi-center collaborative trials, which I think is very important, particularly for uncommon complex cancers like NET. Multidisciplinary collaboration and teamwork is definitely fundamental, based on years of hard work and experience that we've developed in Australia. The goal is obviously to improve outcome for patients with NETs. Doing clinical trial is, however, not easy because we do need support at many, many different levels. Not only do we need funding and resources, we also need support from different healthcare professionals, clinicians, from institutions, relevant bodies from government, national and international support. And I think more importantly, it is really fundamental to acknowledge the importance of the patient advocacy group. In particular, a big thank you to NeuroEndocrine Cancer Australia for the incredible efforts over the number of years for increasing awareness for NET patients, developing clinical pathway, and to support research as well, even by providing some funding for the Australian trials. And I think having a patient perspective is also fundamental as part of clinical trial development. So with that, I would like to thank you very much for your kind attention on a Sunday afternoon. So thank you.
Thank you so much, Grace. And it is exciting. And I know that, you know, it's fabulous to see if there's the future of the development, especially with combination with PRRT. I see Rod has his hand up there.
Yeah, I just wanted to say what a great talk that was, Grace, and how excited I am about the trials that you'll be taking forward over coming years. But one of the groups that I guess I forgot to mention when I was mentioning the multidisciplinary team, which I was reminded of in the copper sartate area, are our radiochemist collaborators and chemistry collaborators. The copper sartate compound was developed at Bio21 on the back of work done actually at ANSTO more than 20 years ago. And Paul Donnelly, who I think is online, and his team did some fantastic work with the sarcophageine chelating agent that we took through our lab, and as you alluded to, took it into a first in human study a couple of years ago. A very short turnaround from concept to delivery, actually, in a phase 1 trial. But the fact that that's now gone into an Australian multi-centre trial is, I think, a great testament to the collaborative spirit of the community. But more than that, it's actually gone into trials in the United States for both diagnosis and therapy with its therapeutic pair copper-67 sartate. The main study centre is the Memorial Sloan Kettering, one of the most famous nuclear medicine and cancer centres in the entire world, that are doing this in children. One of, I think, the earliest projects that you had in the NET area was the use of PRRT in neuroblastoma. And we're incredibly excited about the ability to protect the developing organs of children by doing prospective dosimetry and to deliver a new therapy for those kids. And so it to me speaks brilliantly of all of the groups that come together and the relationship that Paul's group has had with our radiochemists, led by Peter Roselt, I think has been fundamental to this, and how that translates into better outcomes to patients is really a fabulous aspect of the program.
Fantastic, and it is, and it's really exciting. And I think it's also really exciting how many different, the interest in theranostics and a lot more industry will be coming into this space. And we hope with that a lot more advancements, to not only for NETs, but for other cancers. And that's from the pioneers here today. So I will now again hand over to Grace. I think Grace, we're probably now going to do one case. And I will get Grace to introduce our wonderful multidisciplinary team and to talk about the case.
Yes. Hi, thanks, Simone. Thank you very much. I'm sorry we are running a bit out of time. We did actually prepare 2 cases. We'll see how we go. We can maybe go through these cases very quickly. I think it would be good if we can to cover both because they do cover different aspects. If I can ask the panelists to please put your camera on, and I will introduce all of you. You can just say a quick hi to the people. So to the audience, thank you very much for joining the MDT session this afternoon. And I'm joined here by my usual team members from the Upper GI and NET service. So in no particular order, I'm just going through that list down there. Professor Michael, can you please say hi or wave or wink? Hi, we've got, who's the medical oncologist. I think you all know Michael very well. The next is Associate Professor Cherie Chiang. So she's the endocrinologist of our team. Surgical representative, Dr. Ben Loveday. Hi, Ben. And then we have our interventional and diagnostic radiologist, Dr. Phil Chan. Hi, Phil. We have our expert pathologist here, Dr. Bill Murray. Hi, Bill. and very important person, our NET nurse consultant, Meg Rogers. Hi, Meg. And also our important PRT coordinator. Hello, Leah. Hi. Okay. So perhaps we'll try to go through these cases fairly quickly and see how we go. So we've got 2 cases referred to us for discussion today, team. Just trying to advance a slide. Okay, so the first case we've got here is a 52-year-old female who presented with a 12-month history of intermittent abdominal pain associated with vomiting, and also a 10 kilogram of weight loss during that time, as well as some flushing and diarrhea. She actually presented to a local hospital with recurrent abdominal pain. And while she was in the local hospital, they did a CT scan, which apparently showed a mesenteric mass, which means a mass in the abdomen. They couldn't see anything else in regards to a primary lesion or any spread elsewhere. She was found to have an elevated chromogranin A level, which is a biochemical marker, and also had a gallium dotatate PET CT, which was reported as suspicious of NET. So she now has been referred to our MDM for discussion. So the next thing, so referred to Peter Mac, and with a specific question in terms of potential surgical resection. So the next thing we should do is to have a look at the outside gallium dotatate PET CT. So I've got the PET CT up here. You can see the head with the arms up, the chest, abdomen, and pelvis. We do expect some physiological uptake in the liver, spleen, kidneys, and bladder. So that's normal. But in the gallium dotatate scan, after reviewing those images, I found 3 main abnormalities. The first abnormality is that that mesenteric mass that was reported by the outside CT, as you can see, has very high uptake on the dotatate images, which is red here on this projection and black here on this projection, meaning very high somatostatin receptor expression consistent with a NET. The second abnormality that I can see is an abnormal focus down here, which is localized to the small bowel. So very confident that this is a very small primary located in the small bowel. The third abnormality is this very suspicious looking spot in the liver, which I'm very suspicious that there is a liver lesion there. So in summary, I think at this point in time, this patient is likely to have a small bowel neuroendocrine tumor with a mesenteric mass and very likely to have a liver metastasis on GATATE PET CT. So proceeded to have a liver MRI, and I will invite Phil to please go take us through the MRI findings, please.
Hi everyone, thank you, Grace. So today I'm going to be showing you some of the MRI images. And just to give a bit of background, when we interpret an MRI of the liver, we're normally looking at least a dozen series of pictures called sequences. And each of them provides us with a little bit of information, and we need to piece them together to make sense out of that. I wouldn't show you all the sequences, but just highlight some of the more important ones. So first of all here, let's look at the mesenteric mass that was detected on the PET. And let's focus first on the 2 pictures on the left. These are diffusion imaging techniques. And as you can see, the mass is bright on the DWI sequence, which is the one on the top, and it is black on the ADC map, which is the one on the bottom. This means the tumor is very tightly packed, and in this case, with cells. And then on the right-hand side, these are post-contrast sequences where we inject contrast agent through the veins and then image the patient. The PAS does show quite a fair bit of contrast uptake, which is quite bright, and this is quite a common finding in these tumors. And next slide, please. So let's look at the liver. In segment 8, and this is really high up in the liver dome, we see a very bright dot on the restricted imaging on the left and a bright enhancement in the middle picture. And it is here that we need to be very careful with the enhancement pattern. On the right-hand side is the delayed phase with the liver-specific contrast agent. Now, some of the tumors, especially benign tumors, can still have bright uptake like the middle picture, but retain contrast. But in this case, it is darker than the remaining of the liver. So when we put everything together, this is a liver metastasis. Next slide, please. In segment 7, so still very high up, but at the back of the liver, we see a few other bright dots on the restricted diffusion, again on the left side. But this time, on the middle image, we don't see any enhancement, but on the delayed phase, there are again some dots that don't retain contrast. These are also metastases, and the reason why we don't see these bright dots on the arterial phase is because there is motion artifact, and so the pictures become blurry, kind of like trying to take a picture with the phone and the person's moving too quickly, so you lose some of the details there. Next slide, please. And finally, there's one more metastasis in segment 6, which is a little bit lower down in the liver, that shows the same imaging features. Thank you.
Okay, thanks, Phil. So basically now we have a patient with a small bowel primary net with a mesenteric or abdominal mass with 4 small liver metastases in the right lobe shown on MRI. And we know that MRI is much more sensitive in detecting small liver metastases. Don't forget this patient also presented with abdominal pain, which is very suspicious of obstruction or blockage of the bowel, as well as diarrhea and flushing. So what should the next step be? This patient was actually referred for a surgical opinion. So I will ask Ben first, our surgeon, what his thoughts are in regards to removing the primary lesion and nodes, as well as what to do with the liver lesions.
Thanks, Grace. Yeah, when looking at this this case, I'm thinking 2 things. Number one is the primary and its nodes, and then secondly about the liver. Clearly, this person has symptoms from their from the primary in the small bowel. You know, has some gastrointestinal symptoms, and I think it's very unlikely that they are going to go away with some systemic treatment. So giving, you know, chemotherapy or some other treatment like that. And we, even with Prrt, we, you know, tend to think it won't improve those symptoms. So I think surgery is going to be important for removing that small bowel primary and those lymph nodes. So I think that's a fairly easy decision. The question really is around the liver disease. You know, they're quite small metastases. Most of them are fairly superficial in the liver. So I think they would be probably quite easily removed. What we want to do is avoid taking out a large amount of liver, because we know that if someone has metastases already, they probably will develop more in the future, or at least there's a high chance of that. And if we take out too much liver, then that reduces our options for, you know, bigger resections in the future. So I think if we remove any liver, we should just take out just small bits around those metastases and try to preserve as much as we can to leave options there for the future. So that'd be my recommendation.
Okay, that sounds reasonable. I think particularly it sounds like it's a mechanical problem with the abdominal disease. So surgical procedure is certainly a reasonable consideration. Are those mets too small to be biopsied, Phil, of the liver? I suspect they are too small.
They probably can be, but it depends what we can see on the ultrasound. If it's visible, then we can probably have a shot at the segment 6 lesion, which is a little bit further down.
Yep. Right.
I mean, if we're going to recommend surgery anyway, so it's fairly easy for us to take a sample while we're there as surgeons, you know, and we can do a direct ultrasound on the liver intraoperatively. So I think that would probably be favorable.
Sure, and that could be diagnostic as well, I suppose. If you take the liver lesion out, then we can grade it properly as well. Yeah. So I think are there any other objections to surgery at this stage from the panel? If there are no objections, usually, well, the consensus is, as Ben mentioned, to go for surgery to remove the primary and nodes, given the ongoing pain and obstruction, and try to characterize the liver lesions intraoperatively. But I guess before seeing the patient in clinic, Ben, and to talk to the patient about surgery, we should also have a chat to the endocrinologist, Professor Cherie Chiang, because in the context of a patient with carcinoid symptoms, what will be your management option or recommendation before and during operation?
Thank you, Grace. So it's definitely the flushing and diarrhea is very suggestive of carcinoid. And because hopefully by now we would have a 24-hour urine 5-HIAA to have a look at the magnitude of the peptide secretion of this patient. And this patient will need to get started on a somatostatin analog to block the peptide secretion straight away. It's part of the preparation for surgery to avoid a carcinoid crisis.
Yeah, okay, thank you. And how would you usually start the SSAs?
So not knowing the extent of the 5-HIAA, octreotide or lanreotide both have good data of blocking peptide secretion. And for the purpose that we've already made the consensus for surgery to actually give a higher dose, so octreotide LAR 30 and higher dose if the symptoms not controlled. So optimally, we want the patient to have some symptomatic improvement prior to surgery, so that we can make a decision about what needs to be done for prophylaxis to avoid a carcinoid crisis intraoperatively.
Yep, thank you, Cherie. And obviously, I think you usually work together very well with the anesthetic team as well, because they do have very good protocols in place to try to minimize intraoperative and post-operative complications as well. So I was told by Ben that the surgery was then that went ahead and it was uncomplicated. It went really well. So what actually happened in surgery was that the primary lesion was taken out, the lymph node was taken out apparently, and Ben was able to remove the 3 liver lesions and 1 liver lesion was microwaved. Okay, so the next step is really to ask our expert pathologist, Dr. Bill Murray, to show us what Ben actually took out.
Thanks, Grace. So we received about 0.5 metre of small bowel with adjacent mesentery, as well as a segment of liver. So the small bowel had a 16 millimetre tumour within the wall with the typical appearance of a neuroendocrine tumour. And in the adjacent mesentery was a 31 millimetre mass, which looked as though it was a mass of lymph nodes involved by tumour. Microscopically, this is sort of the pattern you see with well-differentiated neuroendocrine tumours, very typical appearance of a small bowel net of the usual serotonin sort of secreting type. If we just go to the next slide. This showed the mesenteric mass actually had a lot of sclerosis with calcification, which you often get with these. Matted nodes which are involved by tumour, and it was also invading blood vessels, which you can see there, and also infiltrating around nerves, and they're all typical ways of these tumours spreading. We did a whole lot of stains on this. We do stains to highlight various things within the cells. I'm not sure we've got those on the slides, but it showed typical neuroendocrine marker. Oh, here we are. Yeah, so neuroendocrine markers, synaptophysin and chromogranin A, both very strongly positive. CDX2, strongly positive. Somatostatin receptor 2, strongly positive, correlating with what you're seeing on the Gaddade scan. And the other thing which we do, which is really important for grading, is what we call a Ki67, which is actually a proliferation index. So we're looking at what proportion of cells are actually cycling. Sorry, I've got a cat on my lap that's screaming at me. Calm down. Okay, so Ki67, when they're done well, you're looking at what proportion of cells are actually cycling. So in that particular field, you've probably got somewhere between 200 to 300 cells, and there's 1 positive cell. So that's a Ki67 of less than 1%. So a very slowly growing tumour. In the liver, you just go back to one slide. We found, so it was a segmental resection. It was about 40 millimetres, I think, from segment 7 and segment 6. And within that, there were 6 small deposits ranging from 0.7 to 3 millimetres, looking exactly the same as what was in the primary. So small bowel neuroendocrine tumour grade 1, because it's less than 3% on the Ki67, metastatic to nodes in the mesentery and also to liver.
Okay, great. Thank you, Bill. I think it's so important to have expert pathology review to help grade these tumors appropriately, because it really determines the management of the patients. So the patients now after surgery has come back to clinic. Basically, we have a patient with a small bowel net, grade 1 tumor. So what would be the next step be? Professor Michael, you will follow up the patient in clinic, and what is your plan?
The plan, thank you, Grace. The plan in this patient's case, assuming that we're fully resected all the disease, would be ongoing surveillance. We would normally see the patient every 3 months with a chromogranin A for the first couple of years, and with structural imaging and functional imaging along the way. We generally would use most likely MRIs to restage the liver and also a GAT8 scan, probably MRI every 6 months, GAT8 scan every 12 months, and monitor the patient symptomatically. In terms of continuing with SSAs, given that we've resected all the disease, we would stop the SSAs after surgery, and there's no evidence for adjuvant SSAs in this situation. Similarly, there's no evidence for the role of any adjuvant chemotherapy following fully resection of grade 1 metastatic disease.
Mm-hmm. But very important that the patient keeps going to the NET clinic for ongoing follow-up, because if anything changes, I guess, then patient will need to be investigated, re-investigated earlier rather than later.
Certainly.
While the patient's at clinic, I think it's also important for the patient to catch up with our NET nurse consultant, Meg Rogers. Meg, you're very important. What sort of support can you actually provide to the patient who has just been diagnosed with a NET?
Well, I would introduce myself, so I would be an ongoing point of contact for this person for support, questions, education, symptom management. And I'd be looking to assess their coping. Do they need any referrals? I'd certainly be referring this person to nutrition, 10 kilo loss of weight, and trying to get a sense of, do they live alone? Are they working, financial compromise by this disease? And I'd also think it's important here to introduce them in terms of patient information and support, additional support to the Neuroendocrine Cancer Australia group. I would give them their written information and encourage them to engage a bit further. Then I just take it from there, establish initial contact, and know that they can contact me again in between consultations with the medical team.
Yep. Thank you very much, Meg. I think it's very important to provide the patient with a holistic management plan. Sorry, given the limitation of time, I think we'll try to do this within 5 minutes. Yeah, the second case. The second case is around a 65-year-old female who was diagnosed with a pancreatic neuroendocrine tumor back in 2016. At that time, it was a grade 2 tumor with a Ki-67 of 15%. Now, the patient at that time had no symptoms and appropriately was started on somatostatin analog, 30 milligrams of LAR. But then the patient subsequently was referred to our unit because of disease progression on CT. At that time, the patient was also found to have very high sugar levels, was requiring insulin and oral hypoglycemic medications to control the sugar levels. And as part of the workup, was found to have a very high level of glucagon, which is one of the hormones that can be secreted by a pancreatic neuroendocrine tumor. So this current picture is most consistent with a glucagonoma. So Bill, can we ask your expert opinion about reviewing the pathology that was done a couple of years ago?
So this patient had a liver biopsy of a lesion in 2018. It was reported at Melbourne Pathology. And so we haven't actually reviewed that at Peter Mac, but these are similar appearances here. Fragmented biopsy with the H&E appearances very suggestive of neuroendocrine tumour. If we go to the next slide, it's important that it's keratin positive. We've got synaptophysin positivity. They also did CD56, which is in the appropriate context is quite useful as a neuroendocrine marker. Chromogranin wasn't expressed in this particular instance. There was staining for SSTR2, and the Ki-67 on the report from Melbourne Path was 20%, which is a bit rounded for me. So when I see a Ki-67 like that, I want to know whether there's been a manual count or not. I suspect not in this case. So, but it's on the border of grade 2, grade 3. So metastatic neuroendocrine tumour, grade 2, grade 3.
Thank you, Bill. So it's a little bit different from the previous case then in this case. So looking at the GAT8 PET CT scan, we can see a clear change of disease progression for this particular patient. So at baseline, there was a pancreatic primary with multiple liver metastases, but you can see now that the number and extent of the metastases have actually increased significantly. And now the patient has also developed a bony metastasis. And outside the liver, there are also lymph node metastases, which is a little bit hard to pick from this particular projection. But corresponding to that, we have a increase in chromogranin A level from 350 to 2,500. And as mentioned before, the glucagon is markedly elevated, consistent with a glucagonoma. We also did an FDG PET scan because this is a higher grade tumor, which shows that some of these lesions are quite active on the FDG sugar PET scan, but of a concordant pattern. So just quickly go around the panel. What should be the next step? Ben, would you do any surgery for this particular patient?
Yeah, so I don't think surgery is going to be a great option. You know, we know that if we could resect or remove at least 70% of the metastases, there would be potentially some benefit. I don't think it's going to be feasible to get 70%. You know, and this person has a pretty high grade 2, maybe even low grade 3 tumor, and so really we want to get nearly all of it out. And if we leave any behind, it will still be producing the glucagon. So I don't think it'll improve any symptoms by removing just some. So it's not a good option.
Okay, thank you, Ben. What about you, Phil? Any liver-directed options for this patient given? Yep.
Yeah, thanks, Grace. As an interventional radiologist, we do have a few options when we encounter patients with liver metastases. One of the more common technology is microwave ablation. We also have several other ablation techniques such as IRE, cryoablation, or even chemical ablation. But these are usually treated for a couple of spots, and unfortunately there's quite a lot of them, so this is not a feasible option. Another way to treat the liver is placing a catheter into the artery through the groin or through the wrist up, and we can block off the blood supply and essentially suffocate the tumor in a procedure called bland embolization. A different version of this is delivering chemotherapy through the liver, and that's called transarterial chemoembolization, or TACE. And finally, there's another treatment called SIRT, which stands for Selective Internal Radiotherapy, or Y90 radioembolization, where we inject millions of carefully calibrated microscopic radioactive beads into the liver, where they travel to the tumor and blast it with very high dose of radiation. Unfortunately, though, for this patient, we wouldn't be able to offer any of these because she does have disease outside the liver. So that means that even if we can effectively treat the liver with any of our techniques, she'll still be left with active cancer cells in her body.
Okay, thanks for your opinion, Phil. Cherie, is there anything else we can do about the hormone control?
Yeah, so glucagon, of course, would raise the blood sugar level, also cause weight loss in many patients. And so we treat them differently to other diabetic patients. The mainstay of therapy is insulin to bring the sugar down. In usual standard diabetes care, a lot of insulin sensitizer is also given, but that generally will cause weight loss and so won't be appropriate. So we'll be titrating according to the insulin and sugar level.
Okay, thank you. Professor Michael, oncological treatment.
If we're considering systemic therapies, Grace, we'd have two options. First one would be systemic chemotherapy in the form of capecitabine temozolomide, which is our preferred regimen in grade 2 pancreatic neuroendocrine tumors, with high response rates up to 50% and progression-free survivals up to about 20-24 months. Based upon a randomized ECOG trial and also a very large retrospective trial reported by the Moffitt Cancer Center just last week. And it's an oral chemotherapy regimen for 2 weeks on and 2 weeks off, and repeat that every 4 weeks. The other alternative would be the biological agents sunitinib or everolimus, which are oral therapies as well, which also have disease control, but shorter durations of control in about 10 to 12 months in these patients. So my preferred regimen would be capecitabine temozolomide chemotherapy.
Okay, and I suspect with everolimus, one of the potential complication or side effect is hyperglycemia as well, so that's probably not too appropriate in this case. I guess PRRT, from the nuclear medicine perspective, is also an option here. Looking at the scans, we know that the tumors are highly expressing the somatostatin receptors. You can see very high uptake here. So we're very confident that we can deliver high radiation doses to the tumor. Based on the NECA-1 trial, it also supports PRRT in the context of disease progression despite SSA treatment, although it was more for midgut NETs, but the approval has been extended to pancreatic NETs as well. Based on our own experience, it is very effective for patients with progressive disease with such high uptake and also good for hormone control. So Michael, I think PRRT is an option here, and perhaps CAP-10 can be reserved as the second option if the PRRT can't control the symptoms very well.
I'd agree with you, Grace. I mean, you probably obviously have greater duration of control, more effective tumoral control with PRRT than you would have with systemic chemotherapy.
Yep.
So our first option here would be PRRT. There are some centres that actually use what's called a sandwich approach, where they give capecitabine temozolomide for a few cycles and interdigitate with cycles of PRRT as well. That's another potential option, but again, it's early days of assessment of that approach.
Mm-hmm. Yep.
And in terms of everolimus hypoglycemia, we haven't actually seen that as a major problem with some of our patients on everolimus, but obviously it is a concern. So if you're going to use a biological agent, I agree perhaps sunitinib might be a more preferred regimen if you're going to use that.
Okay. So do we have general consensus here for PRRT first, and then perhaps a consideration of adding chemotherapy later on? So we'll get the patient to come to the nuclear medicine clinic to have a chat about PRRT, but Leah, being the PRRT coordinator, you're able to provide some logistics and information for the patient.
I am, thanks, Grace. So the first time you will either come in person or via telehealth, depending on your circumstances, and we'll organise treatment usually for about 2 to 3 weeks later if you are deemed suitable. The treatment lasts 3 days, or the process. On the day before, we get you to either phone in or do a telehealth consult just to go through your results, make sure that everything's okay. The treatment day itself, most people are outpatients, and we get you to come in and spend about 5 hours in the department. We send you home, and then the next day we do a scan and a consult just to then go through what's happening, what to expect, that we would like you to have blood tests at 2 and 4 weeks, and that we then give you the dates for your next treatment, which is usually in 8 to 10 weeks after.
Yeah. Thank you, Leah. There's lots of information with PRRT, but Leah is the person to contact if you need any information. And lastly, of course, we'll also introduce Meg to the patient as well, being a patient having PRRT for the first time.
Yeah, once again, Grace, I would be introducing myself as an ongoing point of contact, looking at starting a process of psychosocial assessment, introducing the NeuroEndocrine Cancer Australia group as well, and just assessing their general coping with a new diagnosis.
Thank you. So the patient proceeded to PRRT very well, and just a very quick last slide to show you that this patient has had a very good response to PRRT, not only from the imaging perspective, but biochemically as well. You can see the glucagon level reducing significantly, and the blood sugar control was much better managed. So with that, that's our 2 cases, and thank you very much for joining our mock MDM session.
Thank you so much, Grace. I know that we are running just a little bit on time, over time, and we really want to get to what is such an important part of this this afternoon session, is our tribute to Rod. I think we have just one question that we might ask the panel. Jai, are you able to ask that? I think it relates to proton therapy.
Yeah, thanks, Simone. So question that's come in, it says, I've read that Australia will soon have access to a new type of therapy called protein beam therapy. Could that therapy be useful for some NET patients when PRRT stops working?
Should we direct that to who should we direct that to?
I can comment on that. That actually, I mean, I've had another NET patient ask the very same question this week. Proton therapy is a very highly focused radiation treatment. It's specifically used in patients with brain tumours and tumours of the brainstem, where you need a very pencil-thin beam to destroy the tumour at that site. So it's like with any external beam radiation therapy, it's focalised radiation therapy. And really, with patients, with many of our patients with metastatic disease, it probably would not be of any benefit, unfortunately.
Thank you, Michael. And I know that that is a question that comes up quite a lot. So thank you so much. So without further ado, again, we would like to now present a small but very heartfelt tribute to Professor Rod Hicks and thank him for his incredible years of service to patients, not only here in Australia, but internationally, to his fellows and as the mentor that he is, and it's great to hear from everybody who's been so affected by your incredible work, Rod, and thank you. And after this, we'll have our closing comments from Shelley, and we look forward to continue to work with you, Rod. You will never be a stranger because we won't allow it to happen. So thank you so much, Rod, and look forward to viewing.
Hi, Rod. The R stands for remarkable, the O stands for obliging, the D stands for dedicated. Thank you with all my heart for a second chance at life. Kristen Lepnius.
Thank you, Rod. The dedication of you and your team have given us two things, life and hope. Thank you.
Professor Hicks, I knew as soon as I met you and the team at Peter Mac that I was in excellent hands. You took the time to explain what NETS was. Your amazing knowledge, compassion, and continued reassurance and guidance over the last 9 years has given me my life back, and for that I am forever grateful. Thank you.
Hi, Rod from New Zealand. It's nearly 10 years since Carrie and I sat in your room and you told us that I was suitable for PRT. Thanks so much to you and the fantastic team at the Peter Mac, and on behalf of me and our family and all New Zealand NET patients, thank you so much for everything you've done.
Thank you so much. I remember the moment vividly, and we've had 10 wonderful years, and I cannot begin to tell you how much that has meant to us. So thank you from the bottom of our heart for everything you've done for us.
Hi Rod. Today you and the team at the Peter MacCallum Cancer Centre celebrate an incredible 25 years of providing world-class service for both molecular imaging and therapy. Amongst your many attributes is your passion and your willingness to share your knowledge with others. You will undoubtedly leave a long-lasting legacy. So on behalf of my patients, my team, thank you for all you have done. We wish you all the very best as you venture into new frontiers.
Hi Rod, Grace Kong here. Thank you very much for your contribution to science and for improving the care for patients with neuroendocrine tumors. Your vision and dedication have inspired many people, including me, to achieve much more in this field. Thank you very much, Rod.
Hi Rod. I just want to say thank you for two of the most memorable, exciting and inspiring years of my working life thus far. One thing that stood out above all else was your dedication to teaching and training the future generations and your passion for research and pushing the boundaries of knowledge. So from the bottom of my heart, thank you again for all your wisdom and guidance, and I wish you all the best in the next phase of your life and career, and to your good health.
Dear Rod and friends, it is my great pleasure to say a few words for the celebration of the 25th anniversary of PET at Peter Mac. As a member of the French Connection, I had the great opportunity to spend 1 year in the Department for Cancer Imaging at Peter Mac. And this year has been very inspirational to me and very important in my training. I think with all the team at Peter Mac, Rod has built an incredible department which has always been 5 or 10 years ahead of the majority of departments around the world. And today we are witnessing the incredible development of PET and PRT for neuroendocrine tumors, prostate cancer and other malignancies. So many thanks Rod and all the team for your inspirational works and for your support in training the French nuclear medicine community.
Hi, this is Nicolas speaking from France. I was a fellow at Peter Mac in 2009 and this was by far the best professional experience in my whole life. I am very grateful for that, Rod. I am very grateful for our friendship and for the long-term collaboration we have had since 2009, which led, as you know, to many publications. We all wear here this collaboration as a badge of honor. And we are looking forward to catching up as soon as possible, Rod.
I spent 2.5 years training at the Peter Mac,
And more than training, it was a school of thoughts. There was not only the inevitable Rod rules and elaborate reflections, but also it was where I was taught to center my attention on the disease, to go beyond generic decisions for each patient, and to commit to find a solution that was just right for each specific case. Working with Rod opened me to a network of like-minded nuclear medicine physicians, which allowed me to share thoughts and ideas every day since. And I'm very grateful to be one of the many Hicksians. Thank you, Rod.
Dear Rod, I want to acknowledge once more the tremendous impact you have in the fight against neuroendocrine tumors. I came to Peter Mac for advanced training in PET, but instead of just that, you were an amazing role model for me. I witnessed firsthand your devotion and your compassion when caring for NET patients. This made me refocus my career around diagnostics by establishing our own Prrt program, by getting involved in patient organizations like CNETs, and by building a research program on NETs. Therefore, the impact you have in the life of NET patients is not only felt in Australia, but also in Canada and I'm sure in many other places around the world. Rod, I want to express my deepest gratitude for your mentorship, and I wish you all the best for your upcoming projects. I hope to see you soon. Cheers from Canada.
Rod has always impressed me with his passion for defending the patient perspective, both on national and global level. He is a true champion of change, committed to fight vehemently for the best care possible for neuroendocrine cancer patients, no matter where they live. The way he comes across as a person is marked by his honest and daring nature, while his gentlemanly style and finesse cannot go unnoticed. It is a privilege to know you and work with you, Rod.
Hi, my name's David Patterson. I completed my specialty training at Peter Mac in 2013. The PET Centre was a great place to train, not only because we had access to the latest technology and traces within a world-class oncology precinct, but under Rod's leadership, we also had an innovative approach to leveraging this for the patient's benefit. I still use Rod's rules in my own reporting every day, and each year I distribute a series of his masterclass papers from Cancer Imaging Journal to the next generation of nuclear medicine trainees in Brisbane. This is just one example of how the Peter Mac PET department has played an important role in my development as a nuclear medicine specialist and continues to have an impact on the broader development of the specialty within Australia. Thank you.
My name is Annette Hogg and I'm the Research Manager in Cancer Imaging. I would like to thank Rod for all his support and guidance throughout my career. The research that we've been involved with has covered a diverse range of areas, from the use of novel radiopharmaceuticals in the lab and in the clinic, through to the genetics of tumour development, and finally radiation biology. So it's been an incredible journey, and I just want to thank Rod for his leadership and his support and encouragement during this time. Thank you.
Dear Rod, thank you for being a true NET patient champion, a champion of the science and the research, a champion of the development of new technologies, diagnostics and treatments, a champion of access to these new technologies and treatments, and a champion of the support and care of the individual and their families. I wish you all the best in your new adventure, but I know that you will remain a NET champion in an area that you have shown so much dedication and love to. Thank you so much, Rod.
Professor Rodney Hicks is the consummate physician, educator, scientist, and patient advocate. During his long and distinguished career, he provided exemplary care in his field of nuclear medicine, tirelessly working for his patients, championing targeted therapies and personalised medicine decades before they became trendy. Personally, Rod's attentive and thoughtful care of my sister Kate gave our family years of quality life with her, something that we are forever thankful. Professor Rodney Hicks, you are truly a great physician. Thank you, mate.
thank you very much to everybody that was involved in making that wonderful tribute video. And I want to say thank you as I close now for the most wonderful afternoon. I feel that we've gone everywhere in the world. We went all the way to the start of PRRT in America. We've gone to Europe, we've gone to Canada, we've come back to Australia and New Zealand, and all the way through this wonderful tribute, we have had, if you like, the golden thread of patients and their families' experiences. And of course, that is what we're all here for, aren't we? For patients with NET who are here now, and of course, those to come. I want to say a huge thank you to Simone and NeuroEndocrine Australia. Without such foundations and programs, I know that there would not be as much progress as there has been today. And I look forward to getting you to know you better and to collaborating with each other for many years to come. And thank you for everything that you've brought together today. Can I also say thank you to all the patients, including Ross, that have made themselves available to either be videoed or to have their stories told today. It brings everything so much more alive. And of course, to all of the wonderful multidisciplinary team who took us through all of the stages of diagnosis and treatment planning. That was fantastic to see. Finally, can I say thank you to Grace for taking us through so expertly and clearly the research that has happened, but also the research that is yet to come, showing us that there is a very bright future and we need all to keep on this journey and to break any more barriers. And as Simone said right at the beginning, we're not there yet, so we've still got a lot to do. Finally, can I pay my tributes and respect to Professor Rod Hicks. As Rod knows, I had heard all about Rod and the PET program at Peter Mac before I left the other side of the world. He truly has pioneered in this field. And as we saw today, there are so many people who've been affected by his leadership, patients and families directly, but also many clinicians, scientists who have also benefited from his collaboration and teaching and who are now leading in their areas of the world. So can I just say thank you to everybody? This has been the most wonderful afternoon. I feel very privileged to have been here, to listen and learnt again. And we will together go forward. And as people have said, although Rod may be stepping down from this phase of his work, I am sure he will still always be involved. And perhaps, Rod, I should hand over to the last word to you.
Yeah. Firstly, I just want to thank Simone.
I achieved what I wanted to and made you cry. Good. That's what.
But I want to thank you all, but particularly I want to thank my family who've supported me the last 25 years. I love you all.
Thank you very much, Rod. And thank you, I should say thank you to Jai and I think to Adi, who has been behind the scenes. And once again, what a wonderful afternoon we have had. Goodbye to everybody. And the campaign continues. Thank you very much. Bye-bye.